So now let's talk about electric field due to a point charge. So for example, if you have a point charge here, right now I don't care about whether it's plus or minus. So if you have a point charge here, it does something to the area around it, which we will call electrical field, right? So assume that it does something to the area around it. So when you bring in a test charge, like the charge that you bring in something else in here, and you know that that something else that you're bringing in here is positive, what will it do? Well, once you bring it in here, it will either run away or it will want to go towards it. So if this is a positive charge and you bring it close to it, if this wants to run away, you know that this is going to be a positive, right? On the other hand, if this wants to come towards it, scenario 2, then you know that this is going to be a negative charge. So how do I draw these fields around it? So the way I draw these fields around it, so let me just assume that it is a positive field. This is a rule of thumb. If it is a positive field, all positive charges will have field lines, as we call them, going away from it. Okay? So all positive charges will have field lines that are going away from it. Okay? Now, what do we know about two charges? We know Coulomb law says Q1, Q2 over R squared. We also know that this charge is causing an electric field around it that this other charge experiences. Right? So we can also say F equals QE. Now how do we say this? So let's say I call this Q1. It is I will call this field is due to Q1, and the test charge I will call it Q2. Now how does this work? So this means that combining these two equations, I will get K Q1 over R squared. So the formula, as it is given on your screen here, is actually KQ1 over R squared. So this is the field that Q1 is generating, that our test charge Q2 is experiencing. And it's going away, so we know that both of them are plus. So in fact, E can be reduced down to KQ over R squared. So the electric field due to a point charge is given by KQ over R squared. Remember, electric fields are vectors. Fields are vectors, so they have to be added and subtracted in terms of vectors, not scalars. So I talked about this before. So if this was a positive charge that we were talking about here, if this is a positive charge, the field is going to be radially outwards. However, if it is a negative charge, the field is going to point inwards, as shown over here. So a field going outwards is positive, a field coming inwards is negative.